here approximately, if you want to turn around in the other direction and film.
Oh, yeah.
If you go down a bit, you can see that the opening actually makes a kind of opening where the giant standing stone fits in.
Framing that
It's
giant
framing it,
thing. Yeah,
exactly.
lovely.
Now what's interesting is that that is the exact angle of a 3-4-5 triangle with respect to cardinal direction. And it's also sunrise at winter solstice.
So winter solstice, the sun is coming
The sun rises directly behind the giant
that
standing
giant
stone, which means that the shadow of the giant stone penetrates this. I use the word penetrate on purpose because obviously the stone has a masculine phallic image, and this is a very feminine form. All right, and so the fact that the shadow comes into this form at winter solstice, just when the sun is at its lowest, we call it in French Noël, which comes from Greek novo elios, the new sun. Right? So it's very interesting to see that this is linked to that particular moment. But of course, I say it's on the exact angle of the 3-4-5 triangle. And that only happens at this latitude. If you go further north or further south, you don't get the solstice on a 3-4-5 triangle. Further north, the angle is greater. Further south, the angle is less. And it's only at this latitude that you get that particular coincidence. Now, I say only at this latitude in 5000 BC. Because the sun has slightly changed, the Earth's tilt has slightly changed. We've gone from 24 and a bit now to 23.44.
Oh, right, yeah.
So there's this slight change in the angle of the Earth's tilt. The Milankovitch cycle, 41,000 years. It's not precession.
It's not precession.
No, precession is the circular movement, which is about 26,000 years. The change in the Earth's tilt is a 41,000 year cycle. A lot of people confuse and say, well, the sky's got nothing to do with present and they confuse the precessional cycle of 26,000 years, which points to the stars. And so the pole star will go do a big circle. And so if you're looking at the stars, then the sky changes dramatically between minus 5000 BC and now. The star positions change dramatically. But the solstice positions, the sun's position on the horizon, that changes according to the change in the Earth's tilt, right? And that change is very slight, about 0.7 degrees here since building, which means that you can come here at winter solstice and see the sun directly behind. I've got a photo of it here. There you go. Those are the two opening of the stones. Here's east-west. That's north-south, and the diagonal we saw is the hypotenuse of the 3-4-5 triangle.
3-4-5.
Okay.
That's
so
great.
The corner is actually marked out. So we have 3 points marking out the 3-4-5 triangle. The 3 points are marked by the giant standing stone, by this cornerstone, and by the doorway up there.
So this 3-4-5 triangle is fascinating. I think we recognize that the Egyptians, had a good understanding of this. So do you reckon this is the earliest incarnation of the 3-4-5 triangle that we know about?
As far as I know,
we know about.
As far as I know. Right?
And we're talking about 4,000, 5,000 BC.
That's it. Yeah, 5,000 BC. That's the oldest we know about. Yeah. Although a lot of people don't know about it.
Yeah.
But the interesting thing as well, you see, is the distance, because between there's a specific point on that standing stone, which is the exact angle of the 3-4-5. And so the distance here is 15 megalithic rods, 20 megalithic rods, and 25 megalithic rods on the 5 sides. So the actual measurements here correspond to Professor Thom's megalithic rod, which is 2.5 times the megalithic yard, and orientated. And what's another interesting thing is we saw how at winter solstice the standing stone's shadow penetrated through the female form. Well, 9 months later, it's equinox, the September equinox after winter solstice. 9 months later, September equinox. At September equinox, this is east-west, and so the shadow of the standing stone hits this one, which is like a female form ready to give birth.
Give birth. Yeah.
So it's as if there's some kind of geometrical, cosmic explanation of life. It's very interesting.
Birth cycle encoded in this geometry and the rocks.
Yeah, maths was probably, not as separated from everyday life as it may be now, And the other interesting thing is to see that there's a kind of opening on this stone here, right? There's a sort of shape to it, and its long shape is here. And in fact, the whole stone can be seen as a 3-4-5 triangle, because this angle here is also winter solstice. And so the long axis of this stone is parallel to the hypotenuse of the big triangle, and it's 1/20th the scale. So if you have 25 megalithic rods there, you have 1.25 megalithic rods here.
Nice.
Yeah, it's a 20th, and it's east-west, north-south. Well, they range from about 5 tons. You can get very small ones and very, very big ones. The biggest one is in Loch Mariaker. It's fallen now and broken into 4 pieces, and it weighs 350 tons.
350 tons?
Yeah. And it weighs 350 tons.
350 tons?
Yeah. And it's not a local stone. It's on a sort of peninsula at Loch Mariaker near here. And it's made from orthogneiss, which is kind of layered granite, which is created under the ground because of high pressure temperature. And so that only comes up to the surface at certain spots if there's been some kind of movement, in the crust. And so the nearest quarry is about 12 miles away.
Wow.
And not only the nearest quarry is about 12 miles away, but there is no quarry where you don't have to cross a river. Okay, so there's that massive 350-ton stone was taken to that specific spot, and they must have crossed a river to get there.
Incredible.
Yeah.
Incredible.
So forget about ropes and rollers and all that. A Frenchman called Jean-Pierre Moen, who studied how these stones may have been transported for all of his life. He was a university professor, and he spent all his life studying. And once he retired, he wrote in a science magazine, a French science magazine, in fact, there is no real explanation as to how these stones were moved.
Amazing.
Yes.
Absolutely amazing.
And what I want to do now is show you how this key, all this geometry, is a key to understanding other sites all around the world. Once you've understood this, you can virtually go anywhere and come to terms with the geometry involved in placing these, in creating these megalithic sites. And they're all linked, megalithic or pyramids or ziggurats or whatever you want. They are all linked to latitude. All these sites are placed at specific latitudes linked to this specific kind of geometry. This might sound like an amazing claim, but in the next, how long have I got left? Half an hour, maybe. I'm going to try and prove it to you. So the first elements are going to go along the other diagonal. I'm going to put a point on that corner. And what we're going to do here, first of all, you can see it's 292, right? We're at the angle of the 5, 12, 13. But what I'm going to do is take this line, and I'm going to extend it. I'm going to extend it quite a long way. I'm going to extend it 989 kilometers, right? That's a very long way. We're going to go right across Iraq and Syria. This is the beauty of Google Earth. And we're going to zoom in here near Lebanon. The place names are in French, but I'm going to zoom in here to a place called Baalbek, where we were a little earlier. So let's zoom in. Here's the town of Baalbek. There's the temple up here in the north. Here's the temple. And there's another temple here. There's an angle. Down here are the massive recumbent stones of Baalbek. And the temple's up there. And there's this temple here, which is midway between the two, and which gives an angle. Look at that angle. 292.62 degrees. It's the exact angle to 1/100th of a degree of a 5, 12, 13 triangle. So if you zoom back into, from that line, you zoom back into the ziggurat of Earth, you see that that line goes right along that diagonal. Okay? You taking this in? Yeah, what were the ancients up to? Is that the slogan of Megalithomania? I'd like to say something about Stonehenge. So, we were at Stonehenge yesterday, and what's very interesting about Stonehenge is that the latitude of Stonehenge gives an exact right angle between the summer solstice and the major moon, or the solstices and the major moon. So if you take the major solstice angle, which we saw yesterday, goes to the altar stone, goes down that major axis, and you take the moon angle, the major moon angle towards the south, that creates a right angle. And that will only happen at the latitude of Stonehenge. You won't get a right angle anywhere else. Okay? Pythagorean triangles to get right angles. That's how you do it. And if we take the station stone, so that is the exact angle to 1/100th of a degree precision of a 5, 12, 13 triangle. The same triangle we just saw linked the ziggurat of Ur. Look, let's get the calculator out here, just to show you. If I divide 12 divided by 5 for a 5, 12, 13, that gives me that. Take the inverse tangent, 67.38 degrees. Look at the angle on the map, 67.38 degrees. It is exact, okay? So again here, in 3000 BC, we're not talking about sort of amateurs, sort of vaguely looking at the horizon to link things up. These people the people who did this must have had incredibly precise methods to position exactly over a 3-kilometer distance, a 5, 12, 13 triangle, with a precision of 1/100th of a degree to cardinal directions. And that's what's interesting is then, that gives you a kind of plan for the whole of the whole of the Stonehenge area, because you get the grid going from Stonehenge to Woodhenge as a 5, 12, 13. And this means that from Woodhenge down the Cursus is a 2 by 18. The two station stones that give you the double square here gives you a 3 by 6 point, which comes to a spot here. So this is a suggestion of a geometrical organization of the Stonehenge area. And my time's up. So I hope you managed to follow all that.